Hi guys, so we're going to spend some time in this video addressing the perimeter and area of triangles. So the concept of perimeter has not changed. You're looking at the walking distance all the way around the outside edge of the figure. And so that's listed as side plus side plus side. Keep in mind I'm not trying to tell you all the sides are going to be the same length, because they're not. Just you have to add the sides together. For area, we're going to look at a couple of different situations. The most basic formula for area is base times height divided by 2. And so you'll see in my triangle that I have the base and the height denoted. It's important that we recognize that the base and the height are perpendicular to each other. So they have to come together to create a right angle. And so you might wonder, well, why is that the formula? Well, I'm actually going to draw a slightly different triangle. I'm going to draw a right triangle where you can purposefully see, once my equipment zooms in and out, that we have our base and our height that are sitting there at 90 degrees. Well, if you think about what's going on, and I'm reaching for my highlighter right now, if I were to take that triangle and flip it and have 2 of them, hey, look, that would create a rectangle, or a box, or a square, or a parallelogram, or hopefully something if it would zoom in so you can see it. There we go. So when you look at this whole shape, that's a quadrilateral, rectangle, parallelogram, square, something like that. And so we're looking at base times height, but the triangle itself is just half of that, and that's why we divide by 2. So I'm going to walk us through some problems. I've actually got a couple of other formulas that we're going to play with, but I want to jump into the very first example. And I'm actually using your worksheet, and I'm looking at the evens, which is what I've been consistently doing, so you will be assigned the odds. So I'm going to do problem number 2. I'm just going to sketch it here on my paper. And this is pretty much the way that it's going to look on your worksheet. We have A, B, and C. We are told that A is 7.6 feet, B is 5.4 feet, and C is 9.32 feet. And our task is to do 3 different things. We need to find the area, the perimeter, and then the type. And I'll help you understand what I mean by that once we get through the area and the perimeter. So I'm going to label A and B and C in my picture. I'm actually going to do perimeter first. So we're going to take, that should have been a 5, 5.4 plus 7.6 plus 9.32. Yes, I'm using my calculator. I'm going to have to type it again because I can't type today. Okay, well, I think I typed it correctly finally. So we are looking at a perimeter of 22.32 feet. Remember that perimeter is just plain simple single units. In terms of the area, it's important that we can identify our base and our height because they are perpendicular together. So we're going to take 5.4 times 7.6 divided by 2. And we are looking at an area of 20.52 feet squared. Remember, it's a squared unit because it's basically like the second dimension with respect to area, 2-dimensional figures. In terms of type, I'm asking what kind of triangle do we have? So I'm going to toss out a few words. Right triangle, equilateral triangle, isosceles, scalene, acute, obtuse. This guy, because it has a right angle, is what we would call a right triangle. Remember, and I'll write them down over here, equilateral means all 3 congruent sides and all 3 congruent angles. Isosceles means 2 congruent sides and 2 congruent angles. That will clear up, I promise, I hope. Yes. those are pretty much the three that we're going to be using. If you are seeing something like, well, what about an acute triangle? All three of the angles are less than 90. An obtuse triangle is one in which one angle is greater than 90. And then scalene means that none of the angles, none of the sides are congruent to each other. But these are the three, so there you go. So the next thing that I want to transition to is to take a look at the concept of working with an equilateral triangle. I'm just going to up a little bit so you guys can see that. So an equilateral triangle means that we're going to have three congruent sides and three congruent angles. Now, if the angles are congruent and we have 180 degrees in our triangle, that means that every single one of the angles is going to be 60 degrees. So it's equilateral, meaning congruent sides, and equiangular, meaning congruent angles. So I'm actually going to walk us through problem number 4 in our assignment. And we are told that all of these sides are called S. And S is going to be equal to 7.5 centimeters. And so our task is to find the area, the perimeter, and you're going to notice I'm giving myself more space for the area than the perimeter, and then the type. Let's talk about perimeter. 7.5 times 3, guys, because there are 3 sides. They are all congruent. So let's make this easy. We're looking at 22.5 centimeters. The type, equilateral, because all 3 sides are congruent. So now let's talk about area. So this is where I really wish we had the chance to work together in person in class for a variety of reasons. 1, I wouldn't be dealing with this stinking equipment that keeps zooming in and out. You're probably going to have a seizure. I'm really sorry. 2, I miss you guys. I'd like to be working with you in person. And 3, doing some of this stuff remotely is kind of hard. And so all of the geometry teachers have agreed that we're not going to be able to teach you every single thing that you would have learned in person in class. And so we kind of have to hit what's important. And sometimes that means that you guys are going to have, maybe some formulas tossed at you as opposed to really being able to figure it out from scratch. Some of you might like that, some of you might not. So here is the area for an equilateral triangle. We're going to have the square root of 3 over 4 times a side squared. And you might be like, what? Where did that come from? It works, I promise. You know how we have to find a base and a height? If I were to sketch in a height right here, I would have to do some math work to go figure out how tall that thing is. Well, we would have a 60-degree angle sitting here. This side would actually get cut in half, and we would be able to use, and this is going to be a throwback to way back when, SOHCAHTOA, to figure out how to find the height. So what we could do is we could say this guy right here is opposite, this guy is hypotenuse, and we could say that the SOHCAHTOA, the sine of 60 degrees, is equal to h over s. And then I would multiply s times the sine of 60 degrees, and that would give us the height. Well, the sine of 60 degrees is a constant number, and it happens to be root 3 over 2. And so I apologize, I'm not giving you guys enough room. Give myself a little piece of paper underneath. So the sine of 60 degrees equals h over my side. If I multiply it away, the side times the sine of 60 degrees equals my height. Well, the sine of 60 degrees is root 3 over 2. So that's my height. So if I do base times height divided by 2, my base is my side. My height is my side times root 3 over 2. All of that over 2. That's where the side gets squared. That's where the root 3 comes from. And the 2 2's on the bottom creates a 4. And I know you're thinking, holy crap, Bishop, what? What? Are you crazy? Not making any sense. It's okay. Some of you guys wanted to see where and how it came from, and you're going to go back and rewind and rewind and rewind, and that's fine. Some of you guys are going to be like, how do I do the problem? And that's fine too. So let's figure out how to do the problem. Here's our formula. Area is equal to root 3 over 4 times a side squared. So we're going to take the root 3 and the 4, that's part of the formula, and we're going to take the length of our side, which is 7.5 squared. And we're going to figure that out. I'm going to switch over to my calculator. So on these, I believe the answer key, the way that I had that rolling, was in decimals. So I'm just going to type away. And I know it's kind of dark, but you'll be fine. You can see this. So I'm going to take, I'm actually just pointing at my computer, but you can't see me pointing. I'm going to take my 7.5 and I'm going to square it. So 7.5 squared times the square root of 3. Close your parentheses. You've got to stop that root. And then divided by 4. So we are looking at 24 let's call it 4. Our area is 24.4 centimeters squared. Okay, this is where I want to pause and be like, all right, guys, tell me what that did for you. Does it all make sense? How can I help you with it? But instead, I'm just going to do another example. This is not in your assignment. I'm going to flip my page over, and I'm just going to create one. And I'm going to be like, hey, guys, give me a number. And we're going to go with 4. And I'm going to tell you that that is an equilateral triangle, and as soon as my computer zooms in and you're good to go, you'll agree with me. I'm not going to worry about the perimeter. You guys know how to do that. Let's talk about the area. So the area is the square root of 3 times a side squared, all divided by 4. So I'm going to have my square root of 3 times my side, which is 4 squared, all divided by 4. And I'm literally going to turn on my calculator. And you can type this different ways as long as you close your square root correctly. So I'm going to do my root 3, close the root, times 4 squared divided by 4. Boom. We're looking at an area of about 6.9. Oh, I don't think I labeled it. Let's go inches. Inches squared. Now, I know that some of you guys are currently in Algebra 2 and you're like, whoa, 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 my Algebra 2 teacher would not approve of said answer. They would be like, leave it in roots. Okay, if you want to see this a different way, root 3 times 4 squared over 4. Root 3 stays, 4 squared is 16, the 4 on the bottom reduces, we're looking at 4 root 3. But 4 root 3 is the 6.9 inches squared. Our answers will be in decimal form. You guys are good to go. Okay, so that's 2 equilateral triangles. And my goal is always to make my videos 15 minutes or less, but I fail every single time. So we now need to address an isosceles triangle. So an isosceles triangle is one in which 2 of the legs, 2 of the sides, are congruent, but not congruent to the third. So I'm going to walk us through problem number 6. It's got B and A. So you're going to be told that A is 3.5 yards and B is 5.9 yards. Okay, and I know you guys can find the perimeter. B and A, you'd add it all together once my computer focuses. Come on, it'll come back. And the type would be isosceles. So let's talk about the area. I said it would come back. Come on. Oh, it's not happy. Okay, there we go. So let's talk about the area. What we need to do is we need to figure out a height. Well, that's going to be a little bit of a problem. In terms of figuring, sorry, I'm reaching for another piece of paper here. In terms of figuring out the height, well, what we're going to have to do is we're going to have to recognize that when we drop in this perpendicular, we're going to cut this distance in half. So while A is 3.5, grab my highlighter, this little distance is going to be half of that. So half of 3.5. I know I could do that in my head, but yeah, I'm not gonna. That's 1.75. And B is 5.9. We need my other color highlighter. We need to find the height of our triangle. Well, the way that we're going to do that is Pythagorean theorem. We're going to take the 1.75 squared plus our height squared, that's going to be in yellow, equal to 5.9 squared. And we're going to do Pythagorean theorem. So I'm going to walk us through this. I'm just squaring my numbers as I go. I'm going to subtract over this piece. And h squared is 31.7475. Remember, we have to take the square root of that answer. And h, I'm going to round it to 5.63. There's h. I know you're thinking, oh my gosh, Bishop, it's been forever since we've done Pythagorean theorem. It has, but we've been doing it forever. So you guys know how to do this. We have to cut that one bottom piece in half and then use Pythagorean theorem to find our height. Now, for area, because you know, we're not done yet. We need to take our base times our height divided by 2. Well, our base in this situation is A, and that is 3.5. The height we just spent 27,000 minutes finding, 5.63 divided by 2. So 3.5 times 5.63ish divided by 2. Our area is 9.85 yards squared with some rounding. Oof. We're going to do another one of those. We're totally going to do another one of those. I didn't even make this paper. So this one's going to be problem number 8. So problem number 8, I'm going to give us a little sketch. We're going to have A on the bottom, and A is 4.8 millimeters. We're going to have B at 6.3, that's a couple M's, and another B at 6.3. Remember, this will clear up in just a second. Your perimeter, you're going to add yourself all the way around. You're not going to have any issues. This guy's an isosceles triangle because it's got two congruent sides. Let's talk about the area. So we need to create a triangle inside the triangle. So we have to have a right angle. That means that the 4.8 is going to get cut in half to become 2.4. And we're going to play with this triangle and find our height once my equipment clears up. So we're going to take 2.4 squared plus our height squared equal to our hypotenuse squared of 6.3. I'm actually going to subtract off my 2.4 squared. It saves me a little bit of writing. And so I'm going to do my arithmetic. So 6.3 squared. Can you guys see that? I hate this thing. Can't see it. Can't see it. Can't see it. This is why my videos are so long. So we've got 6.3 squared minus 2.4 squared. That is 33.93 squared. We're going to take the square root of that answer. I know it's second negative, or you can just type the square root of 33.93. I know you can't see it, but you will soon. Our height is 5.8-ish. We're going to be reasonable in our rounding because that's just going to be kind of how we roll. So to find the area, we are going to take base times height divided by 2. Remember that our base is 4.8. The height is what we just worked to find of 5.8 divided by 2. We are looking at an area of about 13.92 millimeters squared. Okay, that's a lot. I recognize that's a lot. You guys are going to be tasked with the odds, but I think I'm only going to give you the 1 through 7. Number 9's a little bit, actually, you can do number 9. Number 9's pretty easy. Take a look at it. It's drawn a little bit weird. If you need help, let me know. I shouldn't say it's easy until you have a chance to look at it yourselves. But you guys are going to do 1, 3, 5, 7, and 9. Miss you guys. Take care. Bye.